Okay, this video will jumpstart the next unit, Unit 4, and we're going to be studying systems of equations. So the first thing to identify is actually what is a system of equations, and it's going to be two or more lines graphed together or analyzed together. So you have a system with two or more lines, and we're just going to analyze them together. The solution to a system of equations is an x-y ordered pair. So you need both x and y to be considered the solution to a system of equations. Let's look at the three possible outcomes. So if you have lines that intersect, this is considered one solution. So that means that you graph your pair of lines. It doesn't have to be a pair, it could be two or more. But when I graph the lines, I have one XY intersection point, and that represents the solution to the system. A different outcome could be lines that don't intersect at all. And when that happens, this is considered no solution. The lines are parallel, and they do not intersect. So you don't have any common XY points. They don't intersect. And then the third outcome, well, actually, you could be given the same line but not recognize that you've been given the same line in two or three different forms. And when this happens, in this scenario, you have infinite solutions because you're actually graphing the same line. So it just means you have one line in several forms, and there are an infinite number of XY points that they would share. So you could have one line in standard form, one in slope-intercept form, and whenever you manipulate or graph, you end up with exactly the same line. So let's look at a few. Let's start analyzing these. Let's start with, well, first of all, let's start with just determining XY solution points. So the first exercise I've given you are little tables. And you can see that each thing that's written in the table, they're all lines. And it doesn't matter what form they're given in, but what I'm wanting you to see is the x and y partner, the x and y ordered pair that comes together. So in the first, you would evaluate the line and let x be -1 and get the y value that goes with that. So if x is -1, then you would have -2 plus y equals +1, and y would equal +3. So the ordered pair here would be -1, +3. Coming to the next value, if x is -4, then you would have -8 plus y equaling +1. So y would have a value of 9. So the ordered pair solution would be -9, or would be -4, +9. And then the third one, if x is +3, then you have 6 plus y equals 1. Y is -5, so the ordered pair solution would be +3, -5. So you're just simply letting x take each of these values, and then you find y, and then the solution, or the ordered pair that would satisfy this equation, or actually the ordered pair that would fall on the line represented at the top of each box. All of these ordered pairs would be points on that line. So I just want you to get used to looking at an ordered pair as a point on a line or a solution to a linear equation. So go through, let x take on each of these values and find the y coordinate partner. And then let's analyze graphing. And then when we have class again, we'll pick all of this up. So the first way to solve a system of equations, the first method that's always taught, is the graphing method. So you would graph each pair of lines, and then you look for their intersection point. And the point where they intersect would be considered the solution. So you can see that all of the solutions are given as ordered pairs. So let's graph this first line, the first pair of lines together, and you'll see what this looks like. And it might even be easier on the video for me to go back and graph what was given on the notes below. So let's just go back to what I had just taken down, and let's do number 1 and 2 together. I'll graph the first line in blue, and I'll graph the second line in green. And we're looking for their intersection point. So the line in blue starts at -8. Okay, it starts at -8, and its slope is +1. So that means that it's going to look something like this. And use a straight edge so that your line is accurate. The second line starts at +1 and has a slope of -2. So you come down 2 and over 1. And even keep going when you hit the intersection point, just to go ahead and just have a complete graph. When the two lines intersect, I'll highlight that in red. That's considered my solution, and that would be the ordered pair x is 3 and y is -5. So the intersection point is my solution. So the object is to graph each line carefully and accurately and look for the point where they cross each other. Let's do number 2 together. So I start with +9 and my slope is 1/2. So if I move down 1 and over 2, down 1 and over 2. And then the second line graphs starting at +6. Starting at +6 with a slope of -1. So that means it's going to fall -1. Here's my intersection point. Let me erase this point. So my intersection point occurs right here, and that would be the x-coordinate of -2 and a y-coordinate of 8, it looks like, -2, 8. And this graph is so tiny on the grid, it's hard for me to see. -2, 8. Yes, that's right. And you can always test the point if you look back at your equations and you let x and y take the value of the point. Both equations should give you a true result when you evaluate them for the point of their intersection. So I will let you take it from here on your own. Just carefully graph, looking for intersection points, and get used to looking for the xy ordered pair as the solution.